And this is MakerspaceCT. This is the blacksmithing area, and it's part of the metalworking and welding area here at MakerspaceCT. And we're gonna go through some safety procedures, setting up, forging techniques, etc., that kind of thing. And then you will be prepared to come in and do some on your own, or with the help of somebody here. Okay, so safety. Safety is super important when forging because the forge is very hot, 2,000 degrees sometimes. And so the pieces you're working on, the pieces of metal that you're hammering, bending, etc., are also in that temperature range, and they can burn you very badly. So you want to be very careful. So all the standards are in play. Eye protection, which I have special safety glasses that fit over my normal glasses. Gloves are highly recommended. Hearing protection, which I'm not wearing at this second, but I will before I start forging. Earplugs are great. Headphones are better, etc. Anything OSHA certified is good. Some of the most important things are your clothing. You want to wear all natural fibers when forging because natural fibers, while they can burn, they don't melt. Synthetic fiber, when it burns, it melts and it can create a really bad burn on your skin. It sticks to your flesh and it gets really bad. So you want to wear all natural fibers. Cotton, leather apron is always good. Leather gloves. You never want to wear synthetic gloves. You always want to wear natural fibers, natural materials. So this leather glove is a perfect example. This is it's been gaff taped back together because the heat melts your gloves and burns through your gloves, and you always want to be safe. I usually just wear the one glove on my hot hand, and because I like the feel of the hammer, I don't really want to wear a glove in my left hand because I need to be able to feel what I'm doing there. Let's see, did I go over there? Eyes, ears, clothing. Some of the other things that you want to make sure, shoes. Shoes, you always want to wear leather shoes. You never want to wear synthetic material shoes. And steel toes are great. I'm not wearing steel toes at this moment, but steel toes are safer than non-steel toes. So, safety. I feel like I've covered everything there, but just general safety in a forge is important. It's a shop where you always want to wear your safety protection, but it's also a shop that's 2,000 degrees. So you want to take that into mind. Let's see, where was I going to talk about next? Oh, the forge. So everything's hot, right? So you really want to, especially in a shared public space like this, other people might be forging at the same time as you. So you want to assume that every piece of stray metal in this area is hot. You never want to walk over and say, oh, that guy that you're working with, that's a really nice piece, and you pick it up because chances are he just took it out of the fire. I'll go over later, but you can tell a lot of information about the temperature of steel and metals in general by their color. And so that's a really helpful piece of knowledge when you're forging, but at the same time, a piece of metal that's fully black, which means it looks normal, can still be up to 700 degrees-ish. So that's plenty hot enough to burn you, and it will be hot enough for quite some time. So just because a piece of metal in the forge isn't glowing red doesn't mean it won't really injure you. So a piece like this, which looks like a normal temperature piece of steel, if it's laying on an anvil, it could be hundreds of degrees hot. So you want to be careful. Another thing is the forge. So this is a gas forge, and there's different kinds of forges. Some run on propane, some run on coal, some run on coke, some run on charcoal, some are even fired. People do a lot of blacksmithing with wood. But this one's a gas forge. So the gas comes out of the ceiling, comes through this manifold, and is dispersed into these 3 jets. And the jets are coming into this enclosed space. And this enclosed space is super insulated so that even though the jets that are coming out of there aren't thousands of degrees hot, the space inside the forge can get up to 2,000, sometimes even more. But that's fire coming out of there. So the fire has to go somewhere. The ends are closed off. So the fire is coming out this way. And that's called the dragon's breath. Sometimes you can see it, sometimes you can't. So you never want to walk or stick your hands or be not in a state of not paying attention when you are in this area, because this space is hot enough to burn you. And that's why we use things like tongs, which are really just pliers that go on handles, so that you can get into that space without entering the danger zone and retrieve your objects. So so if you want to go over there, you don't want to walk through this space, right? You want to create a very wide berth around the forge. This is like a safety zone that you don't want to encroach upon. Some other safety things are technique. And technique is really important with blacksmithing because, like a lot of other repetitive motions, you can receive injuries. And so we'll go over that a little bit later in terms of hammer technique. I'm pretty sure that is everything we have in terms of safety in the forge. So now I think we can begin the process of starting up the forge. Okay? Okay. So, MakerspaceCT has created these wonderful posters to clarify the procedure for safe starting up, startup procedure, and shutdown procedure. And these are super important. So step 1 is turn on the ventilation. The ventilation is over by the main door to the metal shop, and we just did that. So that's good. So you want to turn that knob all the way as far as it'll go. It's a timer, and it will turn on the ventilation, which is this hood, which is going to take all the fumes from the forge and get rid of them. So you want that on. The second thing is the safety switch. And for the key, you have to ask one of the employees here. One of the shop techs will retrieve the key for you. And that's this right here. And there's 2 safety switches. One here by the forge area and one over by the main entrance to the metal shop. Both of them have to be out. So the way these work are, you need the key to turn it on. And then also, it's important to note that if anything were to go wrong here, including fire, injury, danger of any kind, this is the place to go. Press this button, all gas shuts off, all safety is returned, and then you can attend to whatever's happening. But this is the first stop, and in moments of panic, this is where you want to go. And don't hesitate. This is not a big deal. You press this button, the forge shuts off, we can turn it back on. It's no big deal. Feel free to push this button. Now, it sounds like the button is already released over there. So we're all set. So someone has already pulled that button for us. Now this one's all set. So that's step 3 complete. Step 2 is the button by the door. This is step 3. And step 4 is the main wall valve. That's this guy. This is a ball valve. And one thing to know about ball valves is that this is a visual indicator of the position of the valve. This is a wall. This handle is a wall. If it's this way, it's closed, and if it's this way, it's open. So now the wall is this way, the gas can move. So now this valve is open. So that is step 4. Step 5 is to light the forge. So here we have another ball valve here. And the way this forge works is that gas comes in one side, air comes in another side. This is a small fan. And so the air and the gas are mixed in this chamber and sprayed out into the forge itself. So the mixture of air and gas together in different quantities create a hotter flame. So that's what we're after. So the main control valve for the air, or for the gas is here, and for the air is here. Safe way to light the forge is to light a piece of paper, place the piece of paper in the forge. Now you can turn on the gas here without having your hand near the flame, and you can light the forge. So at first, the flame will be big and yellow and kind of scary to be truthful. It's not going to look great. You're going to light the forge with the gas, and it's going to be all gas. And then you reach over here, turn on the fan, and it will make sort of a ignition sound, and then it'll turn into more efficient flames, and then we can adjust the flames here. So I will demonstrate. So as you can see, that's a pretty intense situation, and if you didn't know what to expect, you might be panicked. But really, that's exactly what it's supposed to look like. This gas valve is at, I'm going to say 50 to 60 degrees from vertical, and that's about where you want it. Fully open is too much, and it'll be way hotter than you need it to be. But you should be able to look in there and see that there's 3 columns of flame. So that is the lighting of the forge. Let me just check my poster and see if I forgot anything. No. So that's it. So now adjusting the temperature on the forge is here. The fan is on, you don't need to touch that anymore. Adjusting the heat is with the gas lever. You always want to remove your flammables from this area. And so now this dragon's breath that I was talking about earlier, you can't see it, but there's a lot of heat coming out of here in like this tongue shape, right? So you can put your hand here, like right here, it's already uncomfortable, right? Right here it's uncomfortable. So you definitely don't want to work in this area. Okay, so while the forge is heating up, I'm going to talk a little bit about technique. Blacksmithing is about moving metal, and you're heating up this piece of steel, which is mild steel. You can pick it up at any hardware store or Home Depot. But you're heating it up until it's like a plasticine state. It's a clay-like texture. You can really move it by using this tool, which is a hammer, and squeezing it and pressing it between these two shapes. So the anvil is not moving. Your hammer is moving. But the combination of the hammer and the anvil are suppressing the steel into different shapes. One thing that you want to remember is holding the hammer and the hand position is really important. So I try to work on these two fingers and the base of my thumb to hold the hammer. And the hammer wants to be loose in there. When I was first blacksmithing, I was holding this hammer with a death grip. And the shocks of the impact of the hammer really did some damage to my forearm. It was really uncomfortable. There was an injury, a mild injury. And then the teacher of this class that I was taking said, no, Paul, you really want, this is the only thing that's holding on to the hammer. The hammer wants to be loose in your hand. And you want to raise your hammer above your head and let the gravity of the head of the hammer work and drop that on there. You don't want to be forcing the hammer down upon the metal. You want the gravity to be doing the work for you. So you want to keep your hand loose, and you don't need to hold, everyone wants to hold the hammer way down here. The more control, the higher on the handle you hold it, the more control you're going to have. So it's really very common for me to hold it as high as this. You know, it doesn't feel very macho to hold it that way, but sometimes if you really need to be accurate, you can hold it that way, and then you can adjust. This is where I hold it for most of the forging that I do. It's only in rare instances where I really need to create a lot of power is when I hold it down here, because this is a lever, right? And you have the weight at the end of the lever, and the longer the lever, the more power you're going to get. So when I really want to really get power, I hold it at the very end of the hammer, but in general I'm holding it in the middle here somewhere. And then there's the whip. This is sort of a slow motion of the hammer. It's not like this, like a robot. It's more like the hammer moves in your hand like that, so that you're getting an additional whip at the end of that stroke that creates a lot more speed and power. Thumb. You want your thumb on the side. You don't want your thumb on the edge, on the handle. This creates a pickup point for the vibrations, and it travels up your arm. So you don't want that. You want this to be a nice loose connection. All right? So you want to stand nice and close to your anvil. A lot of amateurs, you know, this is hot. They don't want to get too close. So they're hitting it like this. And this is not a good position for power. The power is here. Sometimes I'm even touching the anvil with my thigh and working like this. You know, you really want to, and in fact, sometimes if my hat's on crooked, I end up hitting the brim of my baseball cap with the hammer. That's how close I'm working. So this is where you create the power, and this is where you have the control. Now, one thing I like to say is blacksmithing is not about strength. You know, blacksmiths have this reputation of being like some big, strong dude. But really, it's not about power at all. It's about repetition and accuracy. If you can hit the steel in the same spot every time, and in this exactly the spot you want, you're going to get better results more quickly and more efficiently than someone who's hitting it really hard and not hitting in the same spot every time. You're just not going to get as much work done as the person. You're hitting it hard and inaccurately. You're not going to get as much work done as if you hit it not as hard, but very accurately and very precisely and in a very repetitious manner. Another thing is that I tend, and what my teachers have taught me to do, is to hit in the same spot on the anvil every time and move your material around so that you can hit the material where you want it. But the repetition that I was talking about is easy to remember. You get this muscle memory so that you're hitting in the same spot every time, but you're moving the material around depending on where you want to hit the material. Those are the basics on technique. Equipment. Obviously, this is an anvil. This is a nice one. It looks like it's in the 250 to 300 pound range, and it's old. A lot of anvils that you see are going to be in the 100-year-old range. There's a formula out there in blacksmithing land that says that the weight of your hammer is a ratio to the weight of your anvil, because the hardness of your anvil and the weight of your hammer, you want equal force going up in a vertical direction as well as down in a vertical direction. So you're creating the vertical, and the hardness and the mass of your anvil are creating the upward direction that counteracts your lower direction. And the more those two balance, the more efficiently you're doing work, right? So that is why blacksmith uses an anvil and not just a hunk of wood, because a hunk of wood would absorb the force of the hammer and it wouldn't create any work on the piece, where an anvil reflects the work created by the hammer and is essentially working both sides of the steel at the same time. So that's the function of the anvil and the hammer. Some of the other basic tools are tongs. This is called a wolf jaw or a flat bit tong, and it has a nice groove here to hold pieces so that you can hold things like that, and that's very secure. You can hold things like this, right? You can hold things like this, although that's not secure, right? And that's why you would hold this on the diagonal and rotate your wrist a little bit to flatten that on the anvil. These are called bolt tongs because that's what they were made for, to make bolts. Because you would put the shank of the bolt in there and the head of the bolt would be here, so that you wouldn't damage the head of the bolt while you're working on the rest of it. These two pairs of tongs I made. Here's another pair of pliers that I made, and that's sort of one of the beautiful things about blacksmithing, is that if you need a tool, you make a tool. All the tools you see here, except for this hammer, which was made by a friend of mine, everything's handmade. You need something, you want to make an object, you make the tools that create that object. So it's a multiple step process. You have the idea in your head, you create the idea, you create the tools that will, in the long run, create the final product. And that's another one of my favorite parts of blacksmithing. So I needed tools to hold this steel, so I made some. And tongs are really important thing, because when you're using a small piece, obviously I'm not going to put this in the forge with my bare hands. You need something long so that you can reach in there and grab it, because it's potentially 1,000 degrees or more. Some other tools are punches and chisels. Move these out of the way. So different shaped hand tools perform different functions. This is a punch, but I also use it as a drift. We'll get to that in a future lesson, but a punch is used to create a hole, and a drift is used to enlarge that hole. This is another punch. It's rounded on the end, so it's called a ball end punch, and that's to create a depression. These two tools work together to set rivets. The head of the rivet goes in this recess, and then this goes into a vise, and then I can work with the rivet on top of that. But in order to create this rivet tool, I needed to create this ball end punch so that I could punch that into the end of this piece of steel and create that depression that I needed for this tool. So in this case, I made a tool to make an object. So there's even another layer. And then this is a chisel. This is a cold chisel. I actually bought this years ago, and it's made for chiseling stone, but it works great for blacksmith tools. And then finally, this tool is also a punch, but I shaped the end to have the geometry of a countersunk screw, so that when I punch that into a piece of material, it creates that shape of a countersunk screw. So those are the hand tools involved. So the basic tools for blacksmithing is an anvil, which doesn't need to be a fancy one like this. It could just be a block of steel that you got from the scrapyard, and a hammer, some material to work with. And those are the three, well, a heat source, which doesn't have to be a big fancy forge. It could be just a propane torch or an acetylene torch. So those are super basic tools. And then when you want to get into doing more elaborate work, you get more elaborate tools and you make them. So you can make tongs, you can make punches, you can make pliers, and these are some of the more advanced tools. And then after that, you can get tools that'll make your life easier, which are power hammers and hydraulic presses and fly presses, all simple machines that magnify mechanical advantage to allow you to get your work done more smoothly and easily. So that is safety and tools. So now I think that we should go into, let me check my notes. I think we've covered most of the introduction. So let's talk about our demo for the day. And I'll cover some other things while I'm doing that. This is what we're going to make. This is a simple hook. Now a teacher that I had taken many classes from, his name is Derek Glazier, look him up, he's amazing, describes blacksmithing as having a bunch of basic skills that can be combined to create as many different projects as you can imagine, right? So let me get my notes so I don't forget. And there's 8 or 9 basic techniques for basic blacksmithing. One is what they call drawing out, which, if you can imagine, this, I started with a piece of stock that was square like it is here. And this is the piece that I started with, looked like that, but it was long, right? So then I drew it out, and if you can imagine this hook being long and straight, the dimension changed from being in a square 3 3/8 square down to almost nothing, so that I tapered it, and that's called drawing out. Cutting is the next thing. A blacksmith can do what's called a hot cut. This hole in the anvil is called a hardy hole, and it holds hardy tools. So you make tools to fit in this square. So this is a blade, and if a blacksmith wants to cut a piece of steel, they don't go get a saw. They heat it up in the forge. They put this piece of steel on the hardy cut tool, and they hit it, and that cuts the steel. So cutting is number 2. Number 3 is called upsetting. And that's a silly word, but it's when you want to take your material and you want to hit the end of it so that it gets shorter and thicker. Sometimes you want to have more mass to work with at the end of this bar. Say you're going to make some nice detail there, like a leaf or an acorn or something there at the end. You need more material than you do on the rest of the bar. So what you do is you heat it up in the forge and you hit it. Sometimes if it's big enough, you just hit it directly on the forge and you squish the end of it, and you're creating this ball of mass on the end, right? That's upsetting. Spreading is something that you see here, which reminds me, this is a really common shape for a blacksmithing hammer. And this has a flat surface on one side and a straight peen on the other side. So the way that works is, you can do the math of the surface area of the face of this hammer. You can do the math of the surface area of the contact surface of that peen. When you're hitting a piece of steel, you're hitting it with all this surface area with force X, right? So that force X is divided amongst that all surface area. When you flip that over, you have this peen, and you hit it with the same amount of force X, that force X is focused into this very small area, which is going to get way more work done, right? So now you can do that on your anvil, which is a flat surface, so that you have your material being pinched between these two. Or what the purpose of the horn of the anvil is that this is a round surface and cross section, just like the peen is a round surface. So now if you work over here, you're focusing the force X of your hammer blow, and you're focusing the reflection of that work on the anvil, and now you're getting a lot more work done on that small area, and you don't have to hit it as many times because you're getting more work per swing. I love to talk about the physics of blacksmithing, in case you didn't notice. Okay. Where were we? Spreading. So this piece is spread. So I took a 3/8 by 3/8 square, and I spread that out to create this little flame shape, right? And the way I did that was I let that hang over the edge of the anvil, and I hit it with my peen like so. So this is a long and narrow piece. And if I hit this metal with my long and narrow hammer, the force of that squishing steel is going to want to go left to right rather than front to back. If I want that to go front to back, I hit it this way, which will force my material this direction, right? This way will force the material this direction, right? So that's called spreading. And you generally use a peen to spread material. Another option is a ball peen. So this is called a ball peen. So this is a flat surface on one side, round on the other. Now if I hit this on my material, it's going to spread the material equally in all directions. But it's going to spread it very efficiently because it's using a very small surface area. So you're really focusing all your force of that blow on that steel, and you're going to get a lot of work done because it's a very focused amount of force. So that's called spreading, because you're using the shapes of your tools to move the metal in different directions. Punching creates a hole, punching a hole. So you use use a punch to punch a hole, and I'll go through that later. The next one is drifting. Drifting is usually in combination with punching. You punch a hole, and then you force a cone-shaped object through that hole, and that cone-shaped object is going to use the simple machine of this ramp to force that hole to be bigger. And so the farther you hammer this through there, the bigger the hole is going to be. That's drifting. Twisting. Twisting is what you see here, where I've twisted that steel. And generally you put the piece in a vise to hold it while it's hot, and then you use something like this, which is called a twisting wrench, that you attach to the steel, and then you twist it, so creating that detail. And that's mostly just a decorative detail. And the last process of blacksmithing that I like to call processes is welding. And we're not going to go over that here today, but we might in a future video, where you heat up two pieces of steel past its critical temperature to the point at which the surface is becoming a little bit liquid. And when that happens, you can put two pieces of steel together, and when you hit it, those two pieces of steel become one. So it's a lot like welding. What you see here, they do electrical welding, but you're doing heat welding, or what you call forge welding. So those are the 9 basic skills of blacksmithing. So you can take all those skills and combine them to create projects. So we're going to make one of these hooks. And so first thing we're going to do is draw out this lower section, which will become the hook. And then we're going to do another draw out on this end. And then we're going to create that leaf flame shape. Then we're going to do some bending to create that hook. And then we're going to do some twisting to create this detail. And then we'll do some punching to create the hole. So, like I said, those 9 basic skills of blacksmithing, you can create a bunch of different ideas and projects. Here's a fire poker. Twist, drawing out, bending, more drawing out, bending, twisting. So you can create a fire poker with all of those basic skills. The same skills as you did to use the hook. What else? Here's a leaf keychain. We use the peen of the hammer to spread that material. We use the chisel to mark marks and create these details. We drew out the stem, and then we bent the stem. So all of those techniques are represented here as well. Okay, so those are the basic techniques of blacksmithing. I'm going to take a break for a minute, get a drink of water, and then we'll start the demo. Okay, so we're going to do this demo of this wall hook. And as I said before, this is a combination of a bunch of different basic blacksmithing techniques to create this project. We're going to make ours a little bigger for the sake of visibility, but I used 3/8 inch square for this one. We're using 1/2 inch square for this one. So it's going to be a little bigger overall. And the proportions might be a little different as well. But the first thing we're going to do is draw out this section. So we'll keep referring to this as we go. So I'm going to use my tongs to handle the steel as we put it in and out of the fire. This is mild steel. Different steels need different times in the forge to come to temperature. Some heat up more quickly than others. I don't know how long it takes to heat up steel. It's really just, blacksmithing is by eye. So what we're using here is your average mild steel. You can get it at any Home Depot, big box store, hardware store, metal supplier, anything like that. And the way you judge the temperature of your steel is color. So when it's room temperature, it's what you call just black heat. So it just looks normal, which is gray, rusty, mild steel color. As it starts to heat up, it goes through a chemical change which causes it to glow. It starts at what people call cherry red to orange to what people call tangerine to yellow, and then on fire, right? It's just like it's saying starting to melt. And believe it or not, you can't burn steel. You get it to that temperature beyond yellow, it starts to spark and burn and break down, oxidize. Fire is oxidation, rapid oxidation. So all of this is oxidation. So obviously this hasn't been in there very long, but this end is black heat. And then you start to see a little bit of glow here. Cherry red is in this area, red, and this, you're starting to see a little bit of orange on the end there. The biggest mistake a new blacksmith makes is trying to work the steel too cold. It's just a waste of time and energy. It needs to be at the right temperature to heat, or you're just gonna have to hit it so much harder to make it do the same thing as if you're just patient, leave it in the forge till it's up to temperature, and then start your work. So the tendency is I can't wait, I want to get back to it, and you pull it out of the forge too early, and now you're just working way harder than you need to. Okay, so another minute. This hammer, blacksmithing hammers come in all shapes. This one's called a rounding hammer. So this side is flat, this side is round. So this acts a lot like what I was talking about before, like a peen. So when you really want to move material, you use this round side. When you want to refine and flatten and create surfaces, you use the flat side. So I'm going to start off with the round side, and then at the end of the heat, I'm going to flip over and refine. So I'm going to move metal with the round side, refine with the flat side. So I'm rotating this 90 degrees. You notice I'm not rotating it 360 degrees because the reflection of the force from the anvil is working the opposite side. So I can hit this side and I'm compressing that steel between the anvil and the hammer, and so I don't need to work 4 sides, I really just need to work 2. So I can rotate between those 2 and create a nice even taper. So obviously this is too cool now. So what I'm going to do is, if you imagine flattening this out, all right, I'm going to create this long taper so that I can curl that up and create that hook. Also, and I'm guilty of this, I tend to work the steel too long. It's much more efficient to work the steel for a short amount of time, get it back in the fire. It takes less time to heat up, which means you're going to be working back at it quicker. So you want to get your work done in quick, short bursts, get it back in the fire, get it back here. So if I work like that time, I worked it all the way to a black heat. Now it's going to take longer to heat up, so I'm waiting more. So you can see that I was working my way down this bar using the shape of the hammer to spread the steel out in both directions. And it was getting all lumpy and bumpy, and that's okay. Then I flipped over the hammer and walked down the piece, flattening that piece out as I went, and refined the shape. So you can see that taper beginning to form. When you're working with steel, you take it out of the fire and it is immediately exposed to oxygen. So the surface immediately begins to oxidize, which was rust. And the scale is formed. Do you see that? And when you're hitting the steel, the scale is very fragile and super thin. That scale is rust. It's immediate. It happens so quickly that every time you take the steel out, work it, put it back in, more rust, more oxidation, you're actually losing material. And your steel is getting a little bit smaller every time you do that. I like to take a minute at the end of every heat, just kind of straighten out my work. Some of those curves and bumps can add up over time and they get to be out of control. Whereas if you just take a second, a few hits at the end of each heat to straighten that out, smooth out some bumps, they don't add up and your piece can stay more clean. And a clean forging is a good forging. So here I'm just refining this taper. So you can see here, this taper starts about here, where it's full dimension there, and it's getting down to about half dimension at the bottom. And you want a nice clean surface that is a nice consistent taper. It's not thicker, thinner, thicker, thinner, and thicker. It's a nice clean, continuous angle. So I will refine this one more heat, and then I'll move to the next step. And the next step will be making this curlicue and then forming the hook. Blacksmiths do a lot of thinking. You really have to be, while your piece is in the fire, you're thinking about what your next move is so that you can work. Once you take that piece out of the fire, you have a clear objective for that heat. And you're not thinking and fumbling, not knowing while your piece is cooling off. Now I'm just going to knock the corners off, which is when you're forging, when you forge two sides, you end up getting really sharp corners. And this project being a coat hook, you don't want any sharp corners to cut into the fabric or ruin a garment or whatever. So you want everything nice and rounded. So you just kind of walk down the corner putting a nice chamfer. And you notice again the detail that I only had to hit 2 corners and all 4 corners are now chamfered because of the reflection of the work of the anvil. So now I'm going to heat this up. I'll curl over the end and then form that hook. And I'm going to be using the anvil for that. Did I say anvil? I'm going to use the horn. This is the horn. Anvil geometry. Face, hardy hole, Pritchell hole, which other tools fit into. This is called the table, where you can do a lot of cutting. Generally, this part is not hardened. Only this part is hardened. And then the horn, which is also traditionally not hardened. But it's tapered so that you can use it to bend, and you can use it to as a peen to draw things out. So now to make this curlicue, I'm going to hang it off the edge and do some just brushing blows to really gently curl that little curl. There you can see I created that little curl on the end. And that little curl is just going to protect your clothing from getting cut. Now another interesting thing about blacksmithing is that you want to isolate your heat. When you're using a coal forge, you can create a hot zone in that fire that will heat you just a really small section of your steel. In a gas forge, you have a lot of trouble doing that. It just heats up the whole thing, which is fine. But when I take this out, I'm going to quench that little curlicue in the water, cool it off. So now that'll be hard. And I can hit it without destroying it, you know, and so I can work areas around it to make a nice curve without destroying that little curlicue. So you want to think about what is hot, because if you're trying to make a nice smooth bend, it's going to bend most when it's soft, where it's hottest, and laced when it's coolest. So to make a nice smooth bend, you want a nice, well-distributed heat. So I'm going to cool this, and now work this. And then you always want to check for straightness. So now I've created that hook, right? I was essentially brushing the steel out over the side of the horn. Hammer blows like this, which creates that curve. Okay. So now we have a much bigger version of this, right? Now we're going to flip this around, cut off the amount we need, and then create this detail on the end. First, I'm going to straighten this a bit. There we go. You want this to be nice and straight before you start. So I'm going to cut off a little bit extra material. Oh, so our skills, right? So far we did a draw. We drew out the end, so that's drawing out. We bent it to create that curlicue and the hook. And now the next thing we're going to do is cut. So that's 3 of our basic skills right there. And then we're going to spread to make that flame detail, twist to create the twisty detail, and then punch to make the hole. Tongs can get really hot, so I just like to keep them cool, because this part gets really hot. It's in contact with the metal, and that heat can tend to crawl up into the handles. So by keeping the end cool, it doesn't tend to do that. So we're going to cut a little bit off the end here. I'm just going to measure by eye. I'm using the edge of the cutting tool. And I want to create a nice clean cut. So this is exactly the kind of thing that I would leave. I would be like, oh, I don't need that anymore. I'm going to put that over there. And then somebody comes along and they're like, oh, there's a little piece of steel. And, it's too hot. They burn themselves, right? So it's a good practice to quench your cutoffs. Or you could just leave it in the water. That's the extra safe way. Okay, now to create that that little flame shape, I want an extra short taper on the end. So I'm sort of hanging this part off the edge. And trying to create a nice little pyramid at the end there. Very short, as short as I can make it. Because in order to have this come to a point, you need to have that come to a point. There's a saying in blacksmithing, it's all about the pre-form. It's all about the pre-work. In order to end up with the shape that you want in the end, you have to create the form that will allow you to get to that. You can't just skip to the end and hope it works out. You have to do the step by step to move the material into the right location to be where you need it when you do your final process. So I'm just going to refine this little pyramid a little more. There we go. So there's a nice little pyramid on the end there. Now I'm going to heat this up. And what I'm going to do is a half face blow, which I'll do that over here to show. I'm going to hang this off the edge. This will be the flame. And I'm going to hit this so that half of my hammer face is on the anvil and half is off. So I'm going to create what's called an offset, which is illustrated here. All right? I'm going to press material down in a way, and at the same time flatten this shape into that little flame shape. It's called a half face blow, because obviously you're half on and half off. And you want to find a nice area. Oh, this is a nice area right here. A lot of times anvils get all chipped up on the edges, and you want a place where it's nice and round and smooth to give you a nice smooth transition. I'm going to use right here. A lot of blacksmiths grind the corners of their anvils to have different radii. It'll be really sharp here, and then it'll be really soft there, a big radius, small radius, because they're in their mind, they know where all the details are on their own anvil, and they use those to create the different shapes that they need. And it's custom to just them. Well, that's not that pretty, but you can see there that I've created that offset and spread that material to be nice and flat. I'm going to heat that once more. These two shapes here. This is a nice, beautiful flame shape. This one is not so nice. Now, I could have done a better preform here, which would give me a nicer, refined shape. Or I could let this cool off and file this into something really nice. So the point there is that don't let blacksmithing defeat you. Make the material what you want. And there's no cheating in baseball. There's no cheating in blacksmithing. If you want to refine this with an angle grinder and a file to make it beautiful, go ahead, do it. Don't feel like that's impure, you know. A real blacksmith would definitely do that. You really just want to make sure that you move the material enough so that you have enough material in the place where you want it, so that you can cut off the material you don't want to make the shape that you do want. Does that make sense? I feel like this forge is hotter over here than it is over there, which makes a lot of sense because the air from the fan is hitting that manifold. Gross. Some disgusting slime on my thing there. Okay. Okay, so we got this nice transition, right? Smooth and flat against the wall. This will be the wall of the hook. And then there's a nice smooth transition there to create that flame at the top. So now our next trick is going to be to twist this section and add that detail. So to do that, I'm going to use this vise, and I'm going to be working right here. This is a custom tool that some friends of mine here at MakerspaceCT helped me make. It's a twisting wrench. It's an old wrench that I found at a tag sale. I blacksmithed this end and then we welded it on here. So you want to pre-shape, if you get your twisting wrench into about the right position. Then I'm going to lock the piece in here and then use the twisting wrench to twist it up. When you're creating a twist, you want your material to be really equally heated, because if one end is less hot than others, you go to twist it, the hotter part will twist faster than the slower part, and you'll get an uneven twist. You can see an example of this here. Not that I like to point out my own mistakes, but see, this is all pretty consistent through here, and then this last twist is a little bit more tight, a little bit tighter there. So it was hotter here than it was through here, which made this twist a little bit more than the rest. And you really just want this to be a nice, consistent twist. Okay, when you're twisting, and this is blacksmith brain, right? You want to be able to think through. Sometimes it even helps to mime the actions so that when you go to do it, you work efficiently and quickly and get the results that you want. So as you can see here, this part was a little hotter than this part up here. This twisted a little faster than this. Now, if that was going to be a problem, I would put it back in the fire, heat up this part, quench this part so that it wasn't going to twist on me, so that this part is cold, and I twist that just a little bit more to match this part. But for the demonstration, I think it's a kind of a nice transitionary twist, we'll call it. Now you can see that this isn't exactly straight anymore. But one thing that you can do, I don't know, can you get me over here? Is you really want to do this with a wooden hammer. Because you don't want to screw up your details. So you want to hammer into something soft so that it doesn't crush your edges. Okay, so there's the hook. We drew out, we bent, we twisted, we spread, and now the last step is going to be to punch that hole. Now to punch that hole, you need a punch. And this is a punch. It's tapered, and it has a very flat, sharp edge at the bottom. And that's what's going to do the cutting. This piece I found a big Allen wrench at a tag sale and forged it into this shape. That's kind of another beautiful thing about blacksmithing, is that you can find steel a lot of places that you wouldn't ordinarily notice it. Like at tag sales, old tools are great. This punch is made from an old car coil spring. Straighten it out, and it's a high carbon steel, which we can go over in another time, but higher carbon steels are hardenable, which means you're changing the chemistry of the tool to be harder than mild steel, so that when you hit mild steel with it, it doesn't change. mild steel does. So to punch, you got to pick your spot. You want to work over a hole in your anvil, and the sharp edge of your tool is going to cut through the steel. So I've created that indent on the other side. Now I'm going to finish the hole from over here. And a lot of times, because this is so thin, you can do it without it being too hot. So you can see that you, rather than drilling that hole, I've punched the hole like you see there. And the part that I punched is right here. I can't pick it up because it's too hot, but I've punched that slug out of that hole. So now the final step is to heat all this up and use this heavy-duty wire brush to brush all the oxide and scale off it to create a nice surface for finishing. And you could paint this, you could oil it, you could wax it, and then it's ready for use. Heat that end up a little bit. What I like to use at home in my forge for finishing is just a little bit of beeswax. Super natural, really easily available, good for you, good for everybody, and food safe, all that good stuff. Not that, you know, you're gonna put your food on this hook, but Like the finish on this spatula is all beeswax. And I made this about 6 or 8 months ago, so it's pretty durable. And then after you use it, you just put a little bit of olive oil or some kind of oil on there just to keep the rust away. And there you go. Coat hook. Thank you. I'm sweaty. So when you're done blacksmithing, you want to shut off the space and shut down safely. And okay. So when you're done blacksmithing, you want to shut off the forge and leave the area nice and clean. Let's start with shutting off the forge. The first step, and by the way, all of these steps are laid out clearly and efficiently on a poster on the wall over there. We'll get to that. First step is to shut off the gas at this valve here. So on is fully vertical. You want to be off, which is fully horizontal. All right? So now we've shut off the gas. The next step is to shut off the wall valve. So we go over here. This valve, which is fully horizontal, needs to be fully vertical. So now this valve is off. The next step is to shut off this valve, which is this push button. And then, of course, you want to take this key and return it to your shop tech or whoever's in charge. Next thing is there's a switch on the back of the fan, and you want to turn that off. So now everything's off over here. And then, of course, the final things you want to do is to hit the button by the metal shop door so that all of this gas stuff is all shut off. And then the ventilation system will go off on its own. But if you'd like to, you can turn that knob all the way to 0 by the door. Now, the most important thing about blacksmithing is that you want to shut all this stuff off 20 minutes to a half an hour before you have to leave the space. That's called a fire watch, because we don't know if maybe there was a piece of paper slid under the table or some kind of flammables in this area, or this hot piece of metal falls off the anvil and touches something flammable. You want to be in this area paying attention for 20 minutes to a half an hour after shutting everything off, so that you're sure everything is cooling off appropriately, nothing's on fire, no one's in danger. And to be honest, that 20 minutes to half an hour is a great time to grab a broom, sweep up your scale, put your tools away, make sure everything is as clean as it is the day you found it, and then when you get back, it'll be ready to go and everybody will be happy. Thank you. And this has been a lot of fun. I hope to make many more of these videos.